We are honored to have Dr. Nick Muhammad Shahril bin Nick Muhammad Nur with us today. Dr. Shahril is a senior lecturer at the University Teknologi Mara UITM Malaysia at the Pematang Puah campus. He holds a PhD in Hotel and Tourism Management from UITM, and his research topic including gastronomy, food culture, behavior, and social science. Dr. Shahril is also an active researcher that involves quantitative analysis and applied statistical method, including the use of PLS SIM. Today, he will guide us through the basic concept and practical application of PLS SIM, especially for researcher and postgraduate students who are early stage for using the statistical method. Okay, without any further ado, please welcome Dr. Nick Muhammad Shahril. Doctor, whenever you are ready, please begin.
Thank you very much, Puan Aniesa, for the kind introduction. I truly appreciate it. First of all, I would like to extend warm welcome and my sincere thanks to all participants who have taken time to join us today. I also see my dearly friend, Saudara Akmal, Bern. Your presence reflects your interest and commitment to continuous learning, and it's an honor to have you all with us. I would also like to acknowledge the organizing committee for the effort in planning and coordinating this webinar. Organizing an online academic event require carefully preparation and teamwork, and I commend everyone involved for making this session possible. Today I will start my sharing session on basic application of PLS SEM. This is my presentation outline. Let's begin. By understanding what PLS SEM actually is. PLS SEM stand for partial least square structure equation modeling. In simple terms, it is a statistical technique that allows us to analyze relationship between concepts that cannot be measured directly, such as attitude, intention, performance, resilience, or innovation. These concepts are called latent variables or construct. PLS work with combining two ideas, which is factor analysis and regression analysis. Factor analysis help us understand how well our questionnaire item represent a construct, while regression analysis help us test relationship between construct. What makes PLS unique is that it focuses on explaining variance and predicted outcomes rather than confirming a perfectly fitting theory. In research, especially in social science, hospitality, tourism, and business study, we often deal with complex human behavior. Data may not be normally distributed, sample size may be limited, and theory may still be evolving. PLS is designed for exactly this situation. Another important point is that PLS is a model-based software. This means we must clearly specify our model before analysis. We do not let the software decide relationship. Instead, theory guides the model and PLS estimate how strong those theoretical relationships are. So at basic level, when you use PLS, you are answering to two questions. Firstly, are my measurement reliable and valid? Secondly, do my theoretical relationship actually works in the real data? Now that we know what PLS is, the next critical question is when we should use it. This is extremely important because using the wrong method can weaken your research, no matter how good that your data is. PLS is most suitable when your research is exploratory or predictive. Exploratory means you are investigating relationships that are not yet firmly established in theory. Predictive means your focus is on explaining and predicting key outcomes, such as intentions, performance, or behavior. PLS is very useful when sample size is small to medium. Unlike CBSEM, PLS does not require large sample. As a rule of thumb, it works well even with 100 or 200 respondents, depending on model complexity. Another key situation is when your data does not allow a normal distribution. In real-world survey research, especially involving perception and attitudes, data is often skewed. PLS is robust against this issue. PLS is also preferred when your model is complex, meaning it has many construct, indicator of path. Instead of simplifying the model to fit statistical requirement, PLS allow the model to reflect reality. Therefore, PLS is not weak alternative to CBSEM. It is a strategic choice that aligns with research objective, data characteristic, and theory development. At this point, students often ask, what is the difference between PLS, SEM, and CB-SEM, covariance-based SEM? Okay, this slide gives a very basic but important comparison. The main difference lies in the objective. CB-SEM focus on theory confirmation, okay, whereby you want to confirm the theory, you're using CB-SEM, okay. It asks whether the data fits an established theoretical model, whereby PLS, on the other hand, focus on prediction and explanation. It asks how much variance in the dependent variable can be explained. CBSEM require large sample size and normally distributed data. This makes it more suitable for mature theories with strong empirical support. PLS is more flexible. It works well with smaller sample and non-normal data. Another difference is model complexity. PLS can handle complex model with many construct and indicator more efficiently. That is why it is widely used in hospitality, tourism, entrepreneurship, and education research. At a basic level, you should remember this. Choose CBSEM when your goal is strictly theory testing and model fit. Whereby, choose PLS when your goal is prediction, exploratory, and theory development. Okay, we focus on PLS because most postgraduate research involve developing and testing model in real-world context, not confirming perfect theories. Okay, we move to main component of PLS SEM. PLS consists of two main components, which is the measurement models and the structural model. Okay, understanding this distinction is absolutely critical because many students make mistake of jumping directly into hypothesis testing, which is in the structural model side. The measurement model deals with the relationship between construct and their indicator. For example, if we say business performance is measured by profitability, sales growth, and customer satisfaction, the measurement model evaluates whether this indicator truly represent the construct. The structural model, on the other hand, examines relationship between construct. This is where we test hypotheses, such as whether innovation capability influence business performance. A key rule in PLS is this: we must evaluate the measurement model first before interpreting the structural model. If your measurement is weak, your structural results are meaningless, no matter how significantly they look. So PLS estimate both models simultaneously, but interpretation must follow this logical sequence. It is like building a house. The measurement model is the foundation. The structure model is the structure built on top of it. In basic application, we focus on reflective measurement model and direct relationship. Advanced models such as formative construct Moderation or mediation will be introduced only after mastering this fundamental. The measurement model examines the relationship between construct and their indicator. Most studies in social science use reflective measurement model, where indicators are assumed to reflect the underlying construct. For example, if satisfaction increase, all satisfaction items should increase together. Okay, there are two types of construct. Okay, which is one is reflective construct. Another one is formative construct. Okay. At the basic application level, students are expected to evaluate three main aspects of the measurement model, which is reliability, convergent validity, and discriminant validity. Okay, reliability tell us whether the item are consistent, whereby convergent validity tell us whether the item is truly represent the construct that you are using. Okay, then we have discriminant validity, which is tell us whether the construct are distinct from each other. We are now focusing on formative model in this lecture because formative measurement require different logics and evaluation criteria. For now, it is sufficient to understand that most questionnaire-based study in society and business use reflective model. Okay, the structure model focus on the relationship between construct. This is where hypotheses are tested. In this stage, we examine past coefficient, their significance, and the exploratory power of the model. The structure model answer questions such as, does innovation capability influence business performance? Does satisfaction lead to loyalty? How much of the variance in the independent variable is explained by the independent variable? Okay, in PLS, we are particularly interested in predictive strength. Therefore, measurement such as R squared and effect size, R squared and F squared, which is effect size, are crucial. At the basic level, you are not expected to perform advanced diagnostic, but you must be able to interpret this core output correctly. Okay, this is example of one conceptual framework. Okay, conceptual framework is important before you start using the PLS. Okay, basic step in applying PLS SEM. Okay. Now let's move to practical application. The first step is preparing the data set, usually in Excel or CSV format. We can also use data from SPSS, whereby we can convert the data from the SPSS format to CSV format. Each row represents a respondent and each column represents an indicator. Missing data and coding error must be addressed before analysis. And also you can use Excel also in keying the data set. Okay. Next, the model is drawn in Smart PLS by creating construct and connecting them with arrow. Based on the conceptual framework, indicators are assigned to the respective construct. After that, we run PLS algorithm to obtain initial estimates. This is followed by bootstrapping, which allow us to test the significance of the relationship. In the second part of for the first part is to test for the measurement models. For the second part, for the bootstrapping, we are testing for the structural model. This step form the backbone of PLS SEM application and must be mastered before moving to advanced analysis. This is some of the sample, the loadings and the R square from the measurement model. The PLS algorithm estimate the model parameter. It produces outer loading, pass coefficient, and R square value. At this stage, we are not testing significance yet. Instead, we are checking whether the model behave as expected. Students should focus on whether outer loadings are sufficiently high or whether R squared value are reasonable. If major issue appear here, such as extremely low loadings, the measurement model may be need refinement before we proceed to the next step. Okay, then to the next second part, which is the structure model. This is the example of the structure model analysis data, which is a pass coefficient, t value, p value, and beta value. Bootstrapping is used to test significance. It involves resampling the data many times to generate t values and p values. In Smart PLS, bootstrapping allows us to assess whether the relationship in the model are statistically significant. At the basic level, students should focus on interpreting p-value and t-value, not on the technical resampling procedure. A p-value below 0.05 generally indicates a significant relationship. Bootstrapping is essential because PLS does not rely on distributional assumption. Okay, for the first part of measurement model evaluation, there are three mains to check, which is reliability, convergent validity, and discriminant validity. In basic PLS application, measurement model evaluation focus on three criteria: reliability, convergent validity, and discriminant validity. These checks ensure that the constructs are measured properly before the hypothesis testing. Student must present this result in a clear table and provide a concise interpretation. Over-analysis is unnecessary at this stage. The goal is clarity and correctness, not statistical sophistication. First, we have reliability. What is reliability? Reliability is assessed using Cronbach alpha and composite reliability, or known as CR. Okay, both indicators should really exceed 0.7. Okay, composite reliability is preferred in PLS because it does not assume equal indicator loading. If reliability value are too low, it suggests that the indicator may not consistently measure the construct. However, the very high values such as above 0.95 may indicate redundancy. Students must report this value and explain what they imply for their measurement quality. Next, we have discriminant validity. Discriminant validity ensure that constructs are distinct. In basic PLS application, HTMT is a recommended criteria. HTMT is known as heterotrait monotrait. Value below 0.9 indicate adequate discriminant validity. Students should report HTMT value in a table and clearly state whether discriminant validity is established or not. There is no need for lengthy discussion at this stage. For chapter 4, we only merely reporting only. Then we have convergent validity. Convergent validity is assessed using outer loadings and average variance accepted, or known as AVE. Outer loading should generally exceed 0.7, while AVE should be at least 0.5. This criteria indicates that the construct explains more than half of the variance of its indicator. At the basic level, we should avoid excessive item deletion and instead justify any decision carefully. Then for the second part, we have the structure model evaluation. In the structure model, students evaluate pass coefficient, R squared value, and effect size, or F squared. The focus is on interpreting relationship, not just reporting numbers. A significant pass coefficient indicates support for hypothesis. R squared show how much variance is explained, while effect size indicate the relative importance of predictor, which is looking into the effect size. While effect size indicate the relative importance of predictors, together, this result provide meaningful picture of the model and explanatory power. Okay, then we have pass coefficient. Okay, pass coefficient show direction and strength of relationship. It is interpreted using beta value, okay, which is showing significance p value of 0.05. Okay, for example of pass coefficient is looking into which is IV to DV. For example, there is an innovation towards performance. The beta value is 0.445 and p value is below 0.01. Okay, looking into the strength of relationship of 45%. Okay, then we have coefficient of determination, which is R square. R square show how much variance is explained. Then we have the rule of thumb. If the R square is 0.75 and above, it is show that the variance explained is substantial. If it's 0.5 and above, this is moderate, and 0.25 and below is weak. Okay, this is the threshold value of the R square. Then we have the effect size, which is F square. Shows the impact of an exogenous construct. The guidelines of or the threshold of the F square is 0.02, which is a small impact size, 0.15 and above, which is medium. Then we have large, 0.35 and above, which is a large effect size. Yeah? You have question?
Sorry for the interruption, Doctor. For
Oh,
all
okay,
participants, please kindly mute your microphone, please. Thank you for your cooperation. Please continue, Dr. Shahril.
All right, okay. The slide is nearly finished. Okay, later we will do a practical. Okay, past coefficients show the strength and direction of relationship between variable, whereby R square show how much variance in the outcome variable is explained. Then we have S square, show the effect size or importance of one predictor. Okay, for the final message, the most important mistake student makes is choosing an analysis method based on familiarity rather than suitability. Methodology should always follow the research question, research objective, and research design. Okay, whereby PLS is a powerful tool, but only when used appropriately. When your studies involve latent construct, complex relationship, limited sample, and predictive objective, PLS is often the most defensible choice. Okay, so remember, strong research is not defined by sophisticated statistics, but well-justified methodological decision. Okay, so I end my slide presentation. Now you can see in the window, I'm sharing the Smart PLS 4. I'm using a Smart PLS 4, the latest version. So version 4.0.9.5. Okay. I will demonstrate a little bit on how students like to use the PLS. Okay, for I will demo. Will demo the how to use use the software. I will show you step by step on how this is the basic basic window for PLS SEM. Then we have PLS new project, we have PLS, we have regression process, CBSEM and GSSA. So we have, if you want to create a new project for your analysis, then I will create one project, one new project. using one of my student analysis. Let's say okay, then after create new project, then we have one file open for your new project. So after that, you have to import your dataset file. Before you can create the model, you must import your dataset file. So you click import data file. So I already create one data file, the CSV file for this webinar. Okay, then click for the dataset file, then we click open. Okay, then we'll pop up a window for CSV import. Then we can see all the data. Okay, this is the data that you have already coded according to your questionnaire. Okay. All scale must be changed into metrics. You click bulk change, click scale, you click metric, then you click apply. Then all will change into metric. Okay. If there any missing value or missing or an error in your data set file, the smart PLS will address it in the missing values treatment. This you can see the value is 0, empty. So the data is okay. So you can click import. When you click import, you will go to the data already import inside the file. Okay, this is the window when you can see all the means, medians, standard deviation, kurtosis, skewness, and all the value. Then you click back. So the data file is already installed inside your folder file. Okay, which is the folder I created is TPB ENT. TPB means theoretical theory of planned behavior entrepreneurship. Okay. Then we click to create model. For model type, we choose PLS SEM. Model name TPB ENT. Okay, then they will bring us to the next window, which is the model creation window. There are list of data set here. You see on the left side of the window, you can see all the data set that we have already already installed inside the folder will appear in the left side of the window. So now, before you start dragging the indicator, this is the left side, we call it an indicator. Before we created a construct, okay, for each construct, then we must first see it must based on your framework. Okay, so the construct must be aligned according to your framework, which is I already say when you drag your indicator and form a construct, then you must name the construct and you become like this model. So now I will show you how to create the construct. You click at your indicator, then you highlight all the indicator in the one construct. You drag out, click at the indicator, then you drag out. Then you name the construct. Then you enter. You have already one construct here. You can change, you can arrange it accordingly. Click the indicator, you can change it where you want to put the indicator. So for this situation, I put it on top. Indicator on top. Okay, then we have one indicator, which is the attitude. Okay. So the indicator A1, A2, A3, A4, A5, A6, A7, and A8, okay, reflects the attitude construct. Okay. Then we have the second one, following the okay, we have a question there. Invert the indicator. You means from reflective to formative. Is that right, Natalie? Oh. Surely it have effect on the analysis. Okay, because formative, let's say if you want to differentiate formative and reflective analysis. For example, let's say, as you can see, okay, this is the formative type, whereby the arrow went out from attitude to the indicator. So the indicator reflects the attitude. For example, I said this is attitude. Okay, so let's say I change the construct from attitude to happiness. Let's say if happiness, so the question will be like this. If you are happy, so if you smile, you are happy. If you are laughing, you are happy. If you are enjoying your life, you are happy. So happy. So the question will reflect the construct happy. So if the the happiness is increased, so with the laughing, smiling, and enjoying life. So if the happiness is declining, also with the indicator, so they are also declining. So you are less laughing, you are less enjoying your life. So the happiness is down, declining. So the indicator reflects the construct. Is vice versa for the formative, whereby the indicator is made by combining of different piece. For example, for formative, for example, school performance. Okay, we want to measure a school performance, so we measure it by exam result, homework completion, class attendance, or any recognition received by the student. So all those things will contribute towards the school performance. So let's say we remove one item from that school performance, it will be it will affect the construct. So I think for time being, it's better we stick it for with the reflective indicator or reflective construct. I hope answering this question from Natalie. Okay. Next, we move on. Then we drag the second indicator, which is the subjective norm. We highlight, then we drag. Then we name the construct. We enter. Highlight. We align it with the attitude. Also the same with perceived behavior control. Then the next one, the last construct. And the last one is this is the construct. Okay, with attitude, subjective norm, collective behavior, and entrepreneurship. Then this is the IV. Then we write the second part, which is the DV. ENT, entrepreneurship, intention. So we are measuring the intention. Okay. So this is the first step of uh, aligning your construct, and before we start the calculation. Then click connect here on the top bar. Then we drag the arrow from IV to DV there. Yeah. If the relationship is okay, it will turn into blue color. Okay. So after you connect all the construct, it will turn into blue in color. Then the connection is complete. Then you click calculate. You can also remove the color from your model. This is your model. Whether you want it color or you want it black and white, you can choose either one. And then you click calculate. When you click calculate button, then we have a standard algorithm. We have PLS algorithm, bootstrapping, blindfolding, and all the calculation. We click the first PLS SEM algorithm. Weighting scheme, we use pass because we are looking into a pass coefficient, looking into pass. Then the weighting scheme is pass. The actual result is standardized. You have unstandardized, mean centered, but you're using standardized. Initial weight default. The data. Okay. After all this, okay, then we click start calculation. Okay. You start calculation. Then the first measurement model. Okay. Now, what do you want to see is the AVE, which is the average variance extracted. You click for the construct, you click here, you choose AVE. Okay. Okay, now you see all the construct AVE is below, above 0.5. The first one is 0.650, 0.5, 0.7, 0.7, 0.7. So all the construct is okay, which is below, above 0.5. After that, we see the construct. We see the indicator, which is the outer loading. Okay, we call it outer loading. Okay, now outer loading for the attitude, all above 0.5. 0.5. Above 0.5. All above 0.5. Okay, we have one below 0.5 there. Okay, then we have one item below 0.5. The item below 0.5, actually, basically, we usually remove it. Okay, check first. All right. So one item from entrepreneurship is below 0.5. This is 0.2. Okay. First, we click save. We save the report. Then we click edit. On the edit part, make sure this button, you highlight the button, blue type, on blue. Because when you delete the item, it will automatically calculate the data. Click delete. Then you delete one item. This EE13. After you delete, it will automatically calculate the new data and save the new report. Save. Okay, this is the first model, which is measurement model. If you want to see the report, you just click open report. The report will show your data here. The loadings. First, the outer loadings matrix. This is outer loading matrix. Okay, the loading for attitude. Green color is okay. Red color also. Basically, red color is not okay. But according to Hensler, if the AVE is above 0.5, you can retain anything above 0.5 from the loading. So we does not simply remove item just because of the loading is low, but we retain some also 0.5 and above, we can retain. It is acceptable. So the loading okay. When you see R square, so the R square shown of the impact size of the intention is 66%. So looking good for the R square. Then we see the effect size, the F square. Okay, for attitude is the effect size is substantial, but for the entrepreneurship, perceived behavior and subjective norm is quite small. So attitude give more impact towards intention. Then we see the reliability. We see the column by alpha. Already listed all the column by alpha. The composite reliability, rho C. Usually we take rho C, composite reliability, and AVE. All shown good indicator that your construct or your indicator towards construct is okay. Then we see HTMT. Okay. Okay, the HTMT all green. Okay, if the HTMT is all green, this is good indicator for your analysis. Okay. If the HTMT is not okay, if you have some of the point or the value is red in color, we have a problem a bit because there are too much what we call the data is too much in the construct or in the indicator is very much the same. Okay. So the concept is too much in similar. Okay, too much in similar, so the value become red above 0.9. So below 0.9, all green is a good indicator for your analysis. And this is the VIF. You want to see the collinearity. VIF is okay. All the model is above 1. We have also another two of discriminability testing. The first one is HTMT. The second one is Phonolacker criterion. How to read Phonolacker criterion? You see, the attitude, the value is attitude is 0.8, 0.806. So it should be larger than other value, 0.7, 0.2. So the TNT tension is 0.873, so it should be larger than others value. 0.894 larger than other value. Larger. Okay, and subjective norm. Okay, larger than other value in their group. Okay, so that's how you read foreign lacquer criterion. Then also we have cross loading. Okay, cross loading. Also, the value, you see, the A is attitude, so the value of attitude should be greater than other construct. 0.584 larger than other construct, larger than other construct. 0.8, 0.8 larger. Okay, this is the indicator that this model is okay. Then we can proceed towards the second part, which is the structure model. Okay, any question on the measurement model before I proceed towards the structure model from the floor?
Everyone, please feel free to share your question in the chat booth or directly to the Dr. Shahril.
It's okay. If no question, we can proceed towards the second part, which is the structure model.
Okay, thank you, Doctor.
Basically, each report, when I want to when for reporting in the, let's say for measurement model, for the reporting part, I will use Excel. I will use Excel, which is, let's say you want to report for R square. Okay. let's say I want to report. Okay, this is how we do the reporting. Copy to Excel. Then you open Excel. We paste. Then we do all the adjustment in Excel first before we paste. Adjust. Okay. We adjust. Then we adjust. We put all the result. We edit them first inside the Excel. Before we transfer it to another document. So now we have the result here. This is the construct. This is the result. Then Then you post, transfer it to your words or your document. It will become from Excel, you transfer to, after you adjust all the detail, the data, the numbers, then you transfer it to like this. Okay, you paste, you see ask the model data. See, then we will run it for structure model. The second part, we click calculate again, then we click bootstrapping. September 2000, we maintain all the 0.05. Okay, start calculation. Then you get the structure model, second part. Okay, save. Bootstrapping. Okay, this, you want to see the pass coefficient. You see all this showing the relationship between attitude towards ENT attention, and all the construct towards the IV towards DV, attitudes, entrepreneurship, education, positive behavior, strategic norm towards entrepreneur intention. You see the P value first. You want to see the P value. P value is all significant. But which is the most significant? Which is the attitude towards intention. Which is the P value is 0.000, and the beta value. This is the original sample. Original sample, you take the beta value. Beta value is where you take from original sample. This is the beta value. 0.444. 44.4%. Okay. So the result for this study showing attitude is the most impact towards entrepreneurship intention. By beta value is 44.4%, and p value is significant 0.00. So you report, this is auto loading, basically auto loading all significant to the graphical output. Okay. This is the so for the hypothesis testing, this is hypothesis testing. H1, H2, H3, H4. So for hypothesis testing, so H1, I already told you the PLS is combining regression also. Okay, so regression comparing which are the most impact or the best towards the IV, towards DV, which is the attitude is the most impact towards the tension by 44.4%. Entrepreneurial education, 8% only. Perseverance control, 22.3, 0.223. Selective norm is 0. Only 90%. So the attitude is the most impact towards ENT attention. There are also another features in PLS SEM, which is a prediction. Okay, we have one PLS predict. Okay, let's predict. Okay, we have here PLS predict. Okay, then we have another one. Okay, which is one of the PLS feature, which is the PLS predict. Okay, PLS predict is it's a tool used to check how good your model is what is predicting at real life situation. Okay, so the calculation calculate the prediction power of your model. So we have so the prediction power is at 64.3%. Okay. So now we save. This is the data for the Q2. Okay, we have this is Q square or the Q2 predict. Save. Then data will be stored inside your folder here. PPB. We have the PLS, the bootstrapping, and the PLS predict. Okay, that's all. My sharing session. Is there any question? Showing you some of the example. See, HTMT. Green, then we have red. So there is a problem between this is from another project from the HTMT customer satisfaction towards customer support. We have a bit of a similarity in question in indicator, customer satisfaction and customer support. Also in customer satisfaction towards delivery support, towards delivery. You see, there is the value is above 0.9. So showing a strong similarity between indicator. Okay, thanks for your time. Is there any question? Doctor, really what you need to be done about? PLS is because of if you think the small indicator, will that okay? When okay, thank you Natalie for the question. Okay, when you delete one of the indicator inside your PLS, usually we reporting it in the table. For example, I'm showing you if there are any delete item. You see, you see in this table, we are reporting it inside the table under notes. Item EE13 was removed due to low loadings. We report it inside the table. We must report any adjustment that we do for the indicator. We must report it. We must report it inside the paper. Really what you need to present about PLS. Okay, basically, PLS result it depends on your basically we want to prove want to test our framework against what we call a theory or else. Okay, then basically the result, let's say for example the entrepreneurship, let's say from the theory part that you use inside your in your study, the theory you use to study, basically if A meets B, it will become C, let's say. Then after you embrace the theory inside your study, then you testing it, you explore it, you test it as result, then it give a different result. The different result is the novelty of your study. Cakap putih dalam ni semua semua ke? Kan? Maksudnya macam itulah. Jadi dia bila kita test something, kita punya teori, total teori tu membuktikan sesuatu bahawa A berjumpa B akan jadi C. Then bila you masukkan teori tu dalam you punya study, then you test the teori dengan PLS. Bila you test teori dengan PLS, the result came out different. So A plus B will become D. So D, then you report on the D, then the D is your novelty of your study. Hope answering your question, Saudara Akmal Burn. Okay. But basically in PLS LCM, we are reporting on the two part, the basic part, which is the measurement model and the structure model. For the measurement model, we are reporting on the R square, F square, on the discriminant variability, the ATMT, the Comet alpha, the CR, which is convergent reliability, ROSI. We are reporting all that. Then, after all this first part showing the good result, then we will continue on the second part, which is the structure model. Structure model, we are reporting and we confirming the hypothesis testing. So, basically, the structure model is for confirming your hypothesis testing. Okay. Thank you. Any question?
Thank you, Doctor, for your presentation. Alhamdulillah, for the detailed and step-by-step, well-structured presentation from Dr. Shahril. I personally also experienced difficulties when using as a early user of PLSM, Doctor, and I see and this webinar give me clarified and many of my personal question, especially regarding the cutoff values for the measurement, the structural model, as well as the hands-on practice using the newest smart PLS software. It's very helpful for us as an early user. And we are moved to the
Is there
Q&A
any
session.
example of report on how we need to report the result? Oh.
Okay.
So the question,
There's
okay,
a question.
thank you, Aniesa. Okay, we have a question from Natalie. Is there any
Natalie,
example
okay.
of report on how we need to report the result? Okay. Okay, I have the
Mrs. Nurina also asked the same question as the
yeah.
Natalie, Doctor.
Wait, I share you. Wait. Okay. This is one of my paper, one of my PhD paper. Okay, that I already do the analysis. Okay, first the measurement model, the sample. So for start, usually I will start with table 1, reflective measurement model, which is consists of indicator, which is the question, the auto-loading, the code, first the code, your coding for your questionnaire, coding, BFR, then your indicator, your question, the auto-loading, the composite probability, rho R, rho C, AVE, and Crombie alpha for each. Then if there any item removed, you stated in the table. You see, we have BFR4, we remove the item. So we address it inside the table. Okay, method cooking. Okay, BD6, we remove also item from food diagram. One item we remove, we address it inside the table. Also, from manual aggregation development, we remove one item also from MH2. This is one way to address item remove. You can also, using the first method, whereby you write one notes below the table, one notes, item, BDR 4, about MH 3 was removed due to low loadings. You can also write this way. Another way, you can write inside the table. You address the item that you remove inside the table. Both can use. Okay, the reporting. Then, after you put the figure, then you report the figure. Measurement model assessment based on the proposed study framework. Okay, the figure. From the PLS, okay, from PLS, the framework or the model that you already sketched, you can copy. Like this. Let's say you want to copy the table. You click left inside the model part, export as image, export. Then the image, you can paste the image in the document. Click paste there. How to paste the model that you already sketched inside the PLS with all the figure. Okay. Next, after reporting on the figure and such, this I use black and white. Okay, then so the reporting is based on it's a yearly reporting. No hanky-panky, just merely reporting. So you report on the CR above 0.8, several item fell, retain. So you see, then you can use hair all. Retention of modality loader when theoretical significance is high and model validity remains intact. On lacquer, so I reporting such a model. Pass coefficient, the R square, the F square, putting also the threshold. Then you see method cooking, F square, 0.432, large effect, medium to large effect, small to medium effect, small to medium effect. Also width, the R square, value moderate to substantial. Predictive, equate Q square, integration, future predict, adaptation. Okay, that's all. The reporting. This is for journal lah. But if for a full paper, it's much more longer lah. For full paper, chapter 4, chapter 5, showing you for the full paper. Okay, showing you my full paper, chapter 5. In my study, I separate analysis into two chapter. For the preliminary analysis, I put inside chapter 4, respondent profile, all the preliminary analysis, I put in chapter 4. Then in chapter 5, I put the mean score all in chapter 4. This is for data collection. Okay, pilot study. Chapter 3. Okay. Okay. Predetermined analysis, I put in chapter 4. What is predetermined analysis? Response rate, summary, overall response rate, then a characteristic of sample, variable, respondent profile, all the graph, all the table, we put in chapter 4, the age and all. Then in chapter 5, mean score reporting, standard deviation and mean score reporting. In chapter 4, preliminary analysis. Then in chapter 5, data analysis and result. In chapter 5, this is my PhD paper. Okay, for chapter 5, quite long. We have initial data assessment first. The reporting first, I report for the initial data assessment, which is the VIF. VIF is a full collinearity testing. Initial data, collinearity testing, reporting. Then normality, I report normality, multivariate normality, okay, using assessment of Madhya coefficient, by showing that my data is not normal. But because using SPSS, PLS, we must use we can use not normal data. Skewness and kurtosis calculation, assessment. Okay, then we have measurement model, refractive measurement model. This is the threshold for the measurement model, threshold and the source, okay, together. The CR, cross-loading, Ponelaka, HTMT, threshold and the source together. Then my model, measurement model, my model is quite complex because you have three mediating. Then reporting on outer loading indicator. This is the table I use. Then internal consistency, convergent validity, discriminant validity, the table, letter variable, I report on the Ponelaka. Also report on the cross-loading. And finally report on HTMT for discriminant validity. After that, moving forward towards structure model assessment. This is structure model assessment. Structure model, my structure model is quite complex because of the, okay, this is the threshold for structure model. If you want, oh, Dr. Shahril nangis. Structure model, this is the structure model threshold. If you want, I can share it with you. Pass coefficient, beta value. Okay. The pass coefficient table. Then we have R square, F square, table also. The S square, we have lots of S square to report. Then we have a Q2 predict, mediating analysis. For mediating analysis, bootstrapping, PLSM, moderating analysis. Then we have the beta value and p value all table. I also test mediating with mediating effect. Sobel test. I also reporting mediation analysis with Sobel test. Sobel test. The table for analysis. After that, summary for hypothesis testing. So the final summary for hypothesis testing. Showing which is supported and which is not supported. Then we have the final model. This is my final model. I like my table colorful a bit to make it more. Okay. Okay, thank you. Any question? Okay, if anything you want to ask question, if anything you want to ask for any help from me, okay, I already type my phone number there, available there. You can message me there.
Thank you, Dr. Shahril.
So you can contact me for anything, help or info. Okay, I'm gladly willing to help you all.
Okay. Okay. Okay, I guess that's all the question for the participant.
Okay, thank you.
Thank you again, Dr. Shahril, for the very insightful presentation. Today, Dr. Shahril has explained the basic theoretical for PLS SIM, the important understanding for us to understand the measurement model, the structural model, as well as the step-by-step practice. And even we get the example to the report result in journal and research chapter in our research report. Alhamdulillah, it's very useful and insightful for us. Once again, thank you very much, Dr. Nik Muhammad Shahril, for your insightful and very structured presentation. And we truly appreciate your time, effort, and willingness to share your knowledge and expertise with us today. And we will also like to thank all participants for your time, attention, and active participation during this webinar. Thank you for staying with us until the end. This webinar also being recorded for the documentation purpose. The recording and the materials and also the certificate of attendance will be shared by the organizer. Please remember to fill up the link of attendance in the chat book. I think that we come to the end of the webinar today. Okay, we hope to see you again in our future event. Thank you and have a blessed weekend, everyone. Wassalamualaikum warahmatullahi wabarakatuh. Thank you so much, Dr. Nik. Please give a round of applause for Dr. Nik Muhammad Shahril. Thank you so much, Doctor. Okay.
Thank you, Dr. Nik.
Inshallah.